A quick question to you guys. Will it be okay if we move this class to Thursday? Not this week, from next week?
Yeah.
Will it be okay? Yeah. Because there are two kids, okay, who are not being able to join, primarily because they have some conflict on Wednesdays. And I'm not going to change it any further. I'm just checking with you guys if Thursday would be okay. I will just move it to Thursday in that case. Hi Dhanushri. So Dhanushri, I was checking with all the kids here that will it be okay if we move this class to Thursday from next week? A Thursday every week? Not this week, from next week. I'm sorry, beta. Say it one more time.
I don't think I'll be able to join because I have another class.
Oh yeah, I have a tournament on Thursday.
On Thursday? Okay. Okay. We'll see that. Okay. All right. Can you guys hear me okay? Okay. All right. So we are moving on to the next unit, which is unit 9. So we have 10 units in total in pre-calculus. We are on the 9th unit now. That doesn't mean that you guys have covered all the units. Since everybody joined in between, so once we finish unit 10, cycle repeats. So that's the way we are able to make sure that everybody gets enough chance to practice and anybody joining in between doesn't end up losing anything. Okay? Alright. I hope the rain is not bothering you guys. It should be a pleasant thing for us in the scorching summer. Alright, so we are starting with unit 9, which is about different series and understanding the details about those. So primarily in this unit we'll talk about two types of series or progression. One is called arithmetic progression and the other one is called geometric progression or series. So a question to you guys, how much you guys know about it? Okay, that's good. Arush, how much you are aware about Dev? So Dev, is this time okay for you? 7:30 instead of 7:15?
This time is okay because my 8 o'clock comes, but usually it doesn't.
Okay. Alright. Okay, just give me a second. Yeah, Deepika ji. You have the link for... Yeah, ma'am, I'm in the class. Do you have the link for the kid to join? I had that in the WhatsApp group itself. I've added it to the WhatsApp group. Yeah. Free calculus, yeah. All right. Okay, so no idea about arithmetic or geometric progression? Dhanushri, Dev, anybody? No idea? Wonderful, that's what I wanted to hear. So then I can teach you right or wrong things. Nobody will be able to assess me, right? Okay. Dhanushri, Dev, any idea you guys have about arithmetic or geometric progression or series? I'm sorry, beta? No idea? Wonderful. That's the news I wanted to come across. Dhanushri, how about you, beta?
Very nice.
Okay. What is that you guys see on the board? I have one group of numbers. I'm calling it series. 1, 3, 5, 7, 9 and it just goes on. And the second series is 2, 10, 50, 250 and that simply just goes on. What is the trend that you see here? What is the trend that you guys observe here?
For the first one, I asked.
I'm sorry?
For the first one, I keep adding by 2.
It keeps adding by 2.
The other add or multiply by the same thing every time.
Say that again.
They either add or multiply by the same thing.
No, this one has a different behavior, this one has a different behavior. So don't relate them together.
Okay, the bottom one multiplies by 5 every time.
Okay. Same thing. Okay. So, Arush, same observation. Dave, Dhanushri, similar observation. Okay. So in this group that you see, here is starting from 1 and every subsequent term is previous term plus 2. This term is this term plus 2. This term is this term plus 2. Yep. Similarly here, this is the starting number and the second term is 5 times of the previous one. Yep. So this is called arithmetic progression. Arithmetic progression. Excuse me for the spelling mistakes, okay? And this is called geometric progression. Now, so this is whatever you guys observed, that's the most important difference between these two progressions of series. When, hello beta, what's your name?
My name is Sunny.
Tanvi. Hi Tanvi, welcome to the class. So this is your first class and we are on unit 9 of pre-calculus. That doesn't mean you have missed everything that we have covered so far. What we will do is, there are total 10 units in pre-calculus. After this one, we will go to the 10th one and then we will repeat the cycle again. Okay? So, no matter who joins when, 6 to 8 months is the time that we need for completing one complete cycle of pre-calculus. And math is a subject that we need to practice. So, don't worry about where you are starting. Any and every concept that we will pick up, we'll be starting from zero, from the basic understanding, and then we'll add more mathematical skill to it. Okay? And Tanvi, the request to you would be, in this class, there are two things that you need to be aware of. One is, you don't have to be busy taking notes, because whatever I'm doing, everything is getting recorded on my iPad. Only me and the board. You guys are not getting recorded. So if you're comfortable, you can turn on your video also. Otherwise, it's fine. And second thing is, this class is meant for making mistakes. Except me, everybody else can make mistakes. I mean, sometimes I also do, but you guys have the option of making mistakes and being confident about it. Okay? So don't think, if I'm asking some questions, whatever you know, you can just share it openly without being worried about somebody or anybody judging us. Okay? So more the mistakes we make, more we learn. That's the idea. Alright, so we are starting unit 9, which is about series or progression. So we just started talking about, there are two types of series. One is called arithmetic series or progression, and second one is called geometric series or progression. Any idea that you had, Tanvi, before I go further into it?
Yeah, I think I remember learning this in algebra 2.
Okay. So then you have a fair understanding. So if I say something wrong, you have an option to correct me. Okay. So now, there are two types of series, as I said. Whether we call it series or we call it progression, both the same thing. Essentially, it deals with a set of numbers, and that the way those numbers are arranged or kept in that group defines the behavior of that group. So when I'm calling this an arithmetic progression, here you see that every subsequent number is related to the previous one, and there's a difference between the two. So, and good thing is, the difference between the first and second number and the difference between the second and third number, difference between third and fourth number are all the same. It cannot be like, okay, first and second has a difference of 2, here you have a difference of 3, and here you have a difference of 7. That will not be qualified to be called an arithmetic progression, arithmetic series. Are we all clear? Similarly, when you talk about geometric progression, it's a multiplication thing. Meaning, every subsequent number is a multiple of the previous number, and every two number relationship is the same. So here to here is 5 times, here to here is 5 times, here to here also will be 5 times. If here to the next one is not 5 times, this whole thing will be scrapped to be called geometric progression of series. Yeah? Meaning each and every element in the series or progression should have the same relationship no matter what. If you see a difference, rule it out. Wonderful. See, somebody celebrating the class. Okay. So we just scratched the surface and we understood what is qualified to be called an arithmetic series or a geometric series or progression. Now let's look at some mathematical aspect. So Tanvi, I'll be asking you a lot of questions because this is your first class. Don't think that I'm trying to put you on the spot. The only idea is I'm trying to get a sense of how far you would want me to go when I'm teaching something, okay? Something that is clear to you, that will be a message for me. Something that is not clear to you, that will be an opportunity for me, okay? Now, so we saw that, okay, let's start from arithmetic series. So here, we saw that, okay, let's pick up another one. Let's say 5, 8, 11, 14, 16. Is this good enough to be called arithmetic series? Challenge me. Yes or no? Little louder, better.
No.
No.
Because 14 and 16 are
Exactly. So the basic criteria for something to be called a arithmetic series is defeated here. Because every two consecutive number have a difference of 3. This guy is 2. So this is not an arithmetic series. If I make this 17, then there is no doubt. Everything is a difference of 3. Now, but if we are talking about 4, 5 numbers, that is okay. If I say find out the 500th number in this series, fun begins. Yep.
This is for me.
Okay. Tanvi, do you remember the formula, beta?
Hello?
Yeah, Tanvi.
Oh, for the 500th term, I think we have to find out what the rule is, which is the first term plus 3 times the term number minus 1.
Okay. Is this what you're saying?
I'm not sure. I think so.
Okay. No, so that's where you guys don't have to treat me as somebody who is here to bother you guys. Okay. I'm just trying to extract as much information I can. Now let's look at it a little closer. Okay. I read these concepts almost 33 years ago. Okay. So it's pretty old for me, and I'm too old for this as well. Now let's look at the behavior when we go into it, right? See, if you remember, the first series that I talked about was like this, and this series I'm starting from 5. So it's always very important to know what is the starting point for the series. Okay, so that's very important. Let's give it a name A. Okay. Here is 5. Now, so by first number, let's say if I call term 1 or element 1, whatever you want to give it, it's always the first number, correct? If I have to go to the second term, what will be that? Don't go that fast. Go, okay, 5 plus what? The common, the difference. The difference is common between two subsequent numbers. This is called common difference. Okay? So 5 plus the common difference. Let's call this as D. Yeah? 5 plus D. Or let's call it A, because we are saying that this is my A is 5, my first number is 5, and common difference is 3. So my second term is A plus D, which will be 5 plus D, 8. So remember this, second term is this. What will be my third term? A. I'm just adding D, correct? What will be my fourth term? A plus 3D. I'm just adding one more term, one more D to it. 3D, A plus 3D. That's why I was asking you guys to go a little slow, because we are trying to wrap our head around this one to derive something more generic in nature. Dhanushri, Dev, am I making sense to you guys so far?
Yes, sir.
Tanvi with me, beta? Tanvi, are you with me?
Oh, yes.
Okay. Anjani, everybody here with me? Okay. Alright. So, we are seeing a pattern here. When we looked at the first term, it was only A. Second term was A plus D. So, second term, 1D. Third term, 2D. Fourth term, 3D. 100th term, A plus number of the nth number minus 1D. And this is our pattern. Look at this again. First term only A. Second term has A plus 1D. So second term 2 minus 1D. Third term 3 minus 1 2D. Fourth term 4 minus 1 3D. Yeah. So for digestible, everybody on the screen. Anjani beta, all good? Sorry, not Anjani. Tanvi. Anjani is right here in front of me. Okay.
All good.
All good? Okay. So now we can put a generic term to it. I'm saying I don't really care what is the value of n. Whatever it be, my nth term will be A plus n minus 1 into D. Now tomorrow if somebody says you have an arithmetic progression, arithmetic series like this, find out the 5000 term. You don't have to keep on adding 3, okay? 5000 terms. So here I'll say element number 5000 will be equal to A plus 5000 minus 1 times D. Now what is my A? A is my 5. My first term, first number is always the most important one that I need to be careful about, so that I know what is my starting point. So this becomes 5 plus 5000 minus 1, which is 4999 times 3. Now everybody knows how to calculate this. Yeah? You don't really have to worry about it. So basically when you look at any mathematical concept, the idea is to generalize this. So what did we do? We looked at how do we relate to something called arithmetic progression or series. Yeah.
Why not just part 1?
I'll take you back. So this is my first term, which has only A, which is my first term. I'm trying to generalize this. Second term had A plus the difference between the two, A plus D. So look at this carefully. Second term, 1D. Third term, whatever was the value for this one, plus D. So this plus D became 2D. Now you see, this is my third term. How many D's I have? 2. So 3 minus 1, that many D's. Then we look at the fourth term. Fourth term will be what? This term plus a D, the common difference. Correct? So that is how the fourth term became my starting number. The first term plus nth term minus 1. So n minus 1, 4 minus 1, 3D. So that is looking like a trend. So we are generalizing that, saying okay fine. No matter which number or element is being asked about, since we know the behavior of this guy, right? Let's say if you are driving on the road, I mean I don't know who all has started driving yet, but once you guys start driving, right? It's just not about you driving perfectly fine. It's about knowing what is the trend of the traffic. If the traffic signal says that 70 miles per hour is the speed, that doesn't mean you can blind yourself and then go at 70. If the traffic is going slow, congestion is more, you'll go slow. When the traffic is very wide open, everybody is going at 90. I would not say go at 90, but we end up following the trend. Okay? So from this trend that we see here, this is the derivation or the generic part that we can derive here. Okay? And we'll see more interesting aspect of it. But before I move on, Dhanushri, Dev and just once again, Tanvi. Are you guys okay, clear about whatever I said so far?
Yeah.
Yeah? Okay. So there are few terms that I use very commonly. One term which is not a very Oxford type term, I call it digestible. Are you able to digest the concept? Okay. So don't hold me accountable for the English that I use, but as long as it makes sense, we are good. Yeah? Okay. Now let's move on. Let's pick up other series. I'm still with the arithmetic series only. Okay? Okay. So I'll keep on dragging you guys back to the class because sometimes it's normal human tendency, right? We tend to get lost in our own thoughts. So that's why. Now let's look at this. Okay. Is this good enough to be called arithmetic series?
Yes.
Everybody agrees to that? Yeah? Dhanushri, Dev, Tanvi, everybody? You have no doubt about me calling this series as an arithmetic series, correct? Now, if I say add first three terms of this series, it's easy peasy. This old man has gone crazy, so he's saying add first three terms. I'll call it sum of three terms, okay? And we will say, okay, 3 plus 8 plus 13. Everybody knows this. 3 plus 8 is 11 plus 13 is 24. What is so unique or special about this? Now, if I want to give you guys or take you for a ride, I'll say, okay, find out the sum of first 200 terms. Fun begins. Now, who wants to tell me how do you get it? And I'm sure you all would have come across this. Arush here, Sahit here. I'm sure Arush will say there's a formula for this, right? But what is that formula? Or any ways. I mean, give me any practical, relatable way to solve this. I have this to solve, otherwise I'll not get my salary next month. How do I do it? Tanvi, any historical reference that you want me to be aware of with respect to this?
I'm not sure.
Okay. So again, beta, just trust me, I'm not trying to put you on the spot, okay? This is your first class and every child in the first class ends up becoming my victim, okay? So don't worry about that, okay? I'm just trying to extract as much information I can. Anjali has gone through it already.
Okay.
Yeah? Okay. Sorry about that. So, okay, now, so I'm not only here to give you guys trouble, I'm here to give you guys some approach also. Now, let's look at it. If I say sum of three terms, yeah? Again, if you're talking about an arithmetic series, you know that most important thing is the first element. That is my starting point. I hope mosquitoes are not bothering you guys. Not yet? Okay, cool. First term is 3. And what is my common difference? 5. That's what we know. Here in this case, let me take a generic approach because my salary is at risk right now. I said, okay, we have to find out some of first 200 terms. Right? So I have to come up with something generic. Otherwise, I might end up having a sleepless night just to sum it up. Tomorrow morning, I have to give the report to my boss. Okay? So, let's look at it. So basically when I'm talking about this, I'm talking about my first term, A, plus second term, plus my third term. See, sometimes you get the symptom of me getting old. Yep. I put a 2D here. That is not correct. So this is how I'm going to systematically add them, right? Now, since I know the value of A and B, I will substitute it and I will get it. Now, the idea is to generalize this. So, let me try generalizing this first. So, let's say sum of n terms will be what? A plus D plus A plus 2D plus. I will go until the nth term that you guys remember we did. A plus n minus 1 into D. That's what we have to sum up, right? And if I am able to replace n with 200, I should be good. But this is still as difficult a task as it was 5 minutes ago. Yeah? But are you guys with me? Yep.
I figured out the formula.
What is that?
It's n of x multiplied with a plus n of parentheses open plus parentheses open n of x minus 1.
Let me just give me a second. Luda.
It's this one.
Okay, hold on to this. Okay, we'll come back to validate that one more time. So this is what we are trying to figure out, right? If somehow we are able to derive this sum of n terms, then we will be able to solve it. Yeah. I don't want to solve it in a very comprehensive way. I'm still trying to find out something more interesting, much more simpler than this. So I was not able to put my thought around this. My brain was malfunctioning. It started malfunctioning because there was stress. So I said, okay, fine. How about me writing the same thing: a plus d, a plus 2d, a plus 3d, a plus 4d, till a plus n minus 1d. Now my brain has flipped upside down. So I'm saying, okay, same thing. I'll write the same thing in a reverse order. A plus n minus 1 times d plus a plus n minus 2 times d. I'm writing the same thing in the reverse order. Let's say sum of 1, 2, 3, 4, 5, 6 is equal to sum of 6, 5, 4, 3, 2, 1. Correct? I'm just writing the reverse order. That's it. And here, in this case, I'll just have a. Correct? This is the same thing written in a reverse order. Correct? Is everybody with me so far? Even if your teacher's brain is malfunctioning, it is still digestible. Correct? Yeah? Tanvi? You like your teacher's brain malfunctioning? Let's see if there's something worthy in it. Okay. Now, I'm saying, okay, how about adding the things which are looking together? If I add these two, what do I get? So here, this is sum of n terms, 2 times sum of n terms. I've just added them. Okay, is equal to what? A plus a, that is 2a, plus n minus 1 times d. This is the sum of the first terms. Now let's add these two also. What do I get? A plus a, that is 2a, plus n minus 2d plus d. How much that will be? N minus 1d? N minus 2d plus a d. How much that will be?
N minus 3d.
N minus 1, n minus 1d. Right? Because here you have n minus 2 plus 1. So it's like this. N minus 2d plus a d. A and a is fine, 2a, right? This is what we are trying to add. So this will become nd minus 2d plus d. What do you have now? nd minus d. Minus 2d plus a d. So if I keep the d out and minus 1, that's what I'm saying here. Am I going too fast or you guys are still with me? Yeah. So we are seeing a trend. When we added, after reversing the order, when we added the first two terms, we got 2a plus n minus 1d. Second term, 2a plus n minus 1d. Let's add the last term also. What do I get? 1a here, 1a here. This is 2a plus n minus 1d. So what do you see here? After you flip the series, okay, not upside down, left side, right, whatever you call it, yeah, and you added the same place value numbers, everything is translating into 2a plus n minus 1d. I will not move forward unless I hear confident yes from each one of you.
Oh, yes.
Yeah? Confident, yes. Shaky, yes. Confident, yes. Okay. Tanvi, Dev, Tanushree. Is this making sense so far? Yeah? Okay. Alright. So, what we saw was, we had sum of n term, that's what we were trying to find out. We said, okay, fine. How about we reversing the sequence and then adding the right place value? And then we saw that everything is adding up to become 2a plus n minus 1b. Now, if you remember this series, okay, we'll come back to this. 3, 8, 13. So here, what it became was 2 sum of n terms is equal to 2a plus n minus 1d. How many times? How many times? How many times? Here. Board gives you all the clue. See, first term, second term, third term, nth term. So you're adding them n times. One more time. So, this is my first term, this is my second term, this is my third term, this is my fourth term, fifth term, sixth term, all individual terms, and this is my nth term. Yeah. So, I have n numbers. First number, second number, third number, fourth number, fifth number, nth number. Yeah. Here, I did not do anything magical. I just flipped it. So, whichever was my nth number is here. N minus 1th number is here, the second place. N minus 2th number is the third place. N minus 4th number in the third, yeah, fourth place. And this is my first number in the reverse order. Now I'm adding the first number with first number, second number with second number, third number with third number, fourth number with fourth number, nth number with nth number. Yeah, and every summation is giving me 2a plus n minus 1d. No, and again, you don't have to rush to say yes. I am okay to go over it one more time. That's fine. But Dhanushri, Dev, Tanvi, I don't get confident without you being confident.
Why did we flip it?
Just for fun.
Oh,
Because just for fun, as in, that was not the right response. Sorry about that. Why did we flip it is because I had no answer why we flipped it. But when you add them, now you have the answer actually. Because when you are flipping it, the sum of the first and the nth term is same as sum of second term and n minus 1 term. Is same as sum of third term and n minus 2 term. Sum of nth term and the first term. It's the same. It gives you the same value, 2a plus n minus 1d. My confidence is shaking right now. Who can make it better? Are you guys clear or not clear?
clear.
Tanvi, Dev, Dhanushri, are you guys clear?
Yes, sir.
Okay, so I'm just repeating it so that it gets glued in your mind. There's nothing fancy about it. I had to find out the sum of n terms and I wrote it the normal way, a plus d, a plus 2d, a plus n minus 1d. That's what we know. We have to find out that. Second thing I did was, okay fine, sum of n terms is this much. I flipped the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is same as 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so I just flipped it. So nth term comes in the first place, n minus 1 term comes in the second place, and the first term comes in the nth place. Yeah. Now we are just adding the numbers. You can put a invisible bracket here so that you know which one you are adding it. When we add that, we get at every place we got 2a plus n minus 1d, 2a plus n minus 1d, 2a plus n minus 1d by adding them. So 2 times sum of the n terms is equal to 2a plus n minus 1d. Now, here if you look at it carefully, this is what? Can I break this into a plus n minus 1d? Is this okay so far? And if you guys remember, this is nothing but my nth term. the thing that we learned. Nth term of any arithmetic progression is a plus n minus 1 times d. Yeah? So what it became? It became sum of 2 times sum of n terms is equal to a, the first term, plus the nth term. Okay? Or whichever way you are comfortable, 2a plus n minus 1d, whichever you guys are able to keep in your hard disk. Okay? That means sum of n terms will be equal to a plus nth term by 2, or okay, here this is n times. So this whole thing was with every place value. So this is n times this one. Okay. So this is n times a plus last term. So this is n times. So this becomes n times by 2, or n times by 2 into 2a plus n minus 1d. Looking cryptic, right? Fine.
I get it.
You got it? Everybody got it? Tanvi, Dave, Dhanushri, did you guys get it?
Yes, sir.
Okay. Okay. So again, do a recap. Nothing fancy, nothing great about it. Sum of n terms is first term, second term, third term, nth term. Nth term is nothing but a plus n minus 1d. We wrote that series, and then we said, okay, if I flip that sum and write the nth term first, n minus first term second, and then we added them together, we saw that first term of the original series versus flipped series, meaning a, and this one was a plus n minus 1d. Adding these two together gave me 2a plus n minus 1d, and this was common for every term. Since we had n terms, so this was, if I had to add them together, this was n times of this whole thing. So that is how 2 times the sum of this was n times of 2a plus n minus 1d, because 2a plus n minus 1d was coming as a sum of every position that we added. Yeah. So now we can look at the generalization of this formula. So based on whatever we saw, right? Again, it might be a little confusing. You guys might end up thinking about it. Don't, or no, it might slip from your mind. Only thing that you have to keep in mind is you first put that in this increasing order, and then you flip it, and then you try adding any two of the terms. So you start with a plus d, and you go on till a plus n minus 1d, and then you flip it. That same thing, if I start from the nth term and then keep decreasing it till you go to a, if you just add the first two positions, you will get it, that this is nothing but 2a plus n minus 1d. And this is just the sum of the first term. Second term is there, third term is there, fourth term is there, nth term is also there. So that basically you are talking about, you are adding this, you are adding it n times. So that is how 2 times your sum of this is n times this thing. Or there are two ways you can, so sum of n terms will be equal to n by 2 into 2a plus n minus 1 times d. This is one formula. Or from this thing you know that, you also know that this is, let's say this is my first formula. Second formula is, I mean, this is just an extension of this thing. 2a I can write as a plus a. And if you look at this piece alone, this is nothing but the nth term. Yeah? So you can also say that sum of n terms will be equal to n by 2 times a plus nth term. So this is your second formula. And both are related, we are just representing them in two different ways, that's it. Yeah? What is everybody's opinion on this one? Is everybody with me so far? I have a very bad nagging habit, okay? Since I don't get confident unless I hear it from you guys, that's why I'm just asking it over and over again, just to be more confident, okay? So, is this part clear to everybody? And you guys can derive it by yourself, okay? Trust me, I just spent 10 seconds to just look at it one more time because I had studied this 3 decades ago. So I had to just look at it one more time and I was able to recall. So I did not remember this formula by memorizing it. I just looked at, okay, how do I find out the sum, and then everything else gets derived by itself. Yeah. Now if we go back to our original problem, that is what I was kind of bothering you all with. That was that, okay, if I have a series 3, 5, 13, 3, 8, 13, 18, and so on and so forth. I was asking you to find out the 200 numbers this series, or sum of 200. So first 200 number will be what? A plus 200 number will be 200 terms will be A plus 200 minus 1 times D, and here your A is 3 and 200 minus 1 is 199 times D, which is 5. So this is 3 plus 199 to 5 will be 995. Yeah. Okay. So this becomes 998. So 200th term will be this much. Now sum of 200 terms will be what? N by 2, n is the number of terms we are talking about, multiplied by first term plus nth term or 200 term. This was one of the formulas that we had derived. Now see how easy the calculation became. 200 terms. So n meaning n, value of n is 200 by 2 multiplied by A is your 3 plus nth term is 998. So this is 100 times, yeah, add 2 more zeros to it. A moment of silence to check if everybody is with me. What did I do? Nothing fancy. I said, okay, we have learned that nth term of an arithmetic series is nothing but A plus n minus 1 into D. Here we are talking about 200 term. So by 200th term is A plus 200 minus 1 D. A is 3 by first term and 200 minus 1 is 199. And my D is the common difference between any two consecutive number is 5. So this gives me, okay, did I do it right? 5 plus 4 plus 9. Yes, okay. So nth term we got as 998, and the formula that we had learned for sum of n terms was n by 2 times A plus nth term, or the first formula that we had learned was sum of n terms will be n by 2 multiplied by 2A plus n minus 1D. Whichever you guys remember on the fly, that's what you can apply. So 200 by 2 in bracket 2 times A is 2 times 3 is 6 plus 199 into 5. Yeah, into the center. Is everybody with me? Am I only teaching myself or am I reaching you all?
I understand, sir.
Okay, Dave, how about you, beta?
I understand, sir.
Tanvi, what would be your response, beta?
I got it, sir.
You got it? Okay. So, now what is the message for you all? Am I asking you guys to memorize this? No, I'm not. I don't want you guys to memorize it. It hardly takes 2 seconds to derive this formula. I mean, if you memorize it, that's good. I don't lean on memory. I mean, my memory is pretty weak. Anyways, with age it has started fading actually. Okay, my memory is corrupted. You guys might be better off, but here you will see that if you forget, it's okay to forget, as long as your sequence of event. I'm telling you a story, okay? I'm saying that okay, sum of n terms is if you have to add them, just flip it. Add these two terms, you will get the same value 2a plus n minus 1d, and that becomes your clue. Oh, everything is becoming 2a plus n minus 1d. And we have how many terms? 9 terms. So adding these two, this means 2 times sum is equal to this multiplied by n. 20 seconds stunt, that's it. If you memorize it, you will actually end up memorizing it when you practice few problems, right? When you do the unit test in Khan Academy or any test material that you want to practice with, once you practice it, then it becomes a part of your memory, which I call as muscle memory. Muscle memories are better actually, right? I mean, when you learn driving, you don't have to keep on recollecting all the rules, right? It just basically your body knows how to reflect, not reflect. How the body's reflex will help you drive, right? Same thing here. So when you practice it, it will become yours. Yeah. So you can derive this formula. Similarly, nth term, it's easy. You starting with a, you're going to a plus d, you're going to a plus 2d, you're going to a plus 3d, and this first term has no d. 1 minus 1 0d, 2 minus 1 1d, 3 minus 1 2d, 4 minus 1 3d kind of thing. So nth term will be nothing but a plus that term minus 1 into d. There are two things. I mean, I'm saying that you don't have to memorize, but at least you have to be able to relate. As long as you're able to relate, it will be easy. Yeah? Some smiling and confident faces. No smile. Okay. Alright, so everybody understood this, right? Yeah? Alright. So let me do one thing. I would quickly turn on the light because I see it's getting darker. Okay. Do we all have the energy to jump onto the next one, which is called geometric series? Yeah? We have 12 minutes. We can finish geometric series in 12 minutes? No, we'll not try to. We'll not try to. Let's at least get a hang of it. Okay? It's not about completing things. It's about absorbing the concepts and then holding on to it. Yeah? So geometric series, if we talk about, we saw series like this. What is the difference between arithmetic and geometric series is? In arithmetic series, you are adding, basic arithmetic, addition, subtraction kind of thing. Okay? Here, we are talking about multiplication or division. So, that's how you can logically or illogically break it. That when I am talking about addition or subtraction, that is arithmetic series or progression. When I am talking about multiplication or division, I am talking about geometric series or progression. Now you'll say, sir, you only taught us addition with the first one. Where is the subtraction coming from? Any thoughts? Did we see a subtraction in arithmetic series? Can we have subtraction in arithmetic series? Yes or no? On the screen, can we have subtraction also in arithmetic series? Dhanushree, Dev, Tanvi. See, when we talk about arithmetic series or progression, we talk about addition, right? My question is, can we think of subtraction also being part of arithmetic series? Think about it. Let me hear, Arush.
You can add by a negative number.
Exactly. Did I say we have to add? No, I said the difference between two consecutive number, and the difference could be a negative difference also. Meaning, if I have 1, 6, 11, 16 as arithmetic series, I can also have 19, 16, 13, 10, 7 as arithmetic series also, because my difference between two consecutive number is fixed. Here the difference is -3, here also -3, here also -3. So it's only about the difference, it's not about sum. So here, in this case, your A is 1 and your D is 5. In this case, your A is 19 and your D is -3. Nobody is stopping us from qualifying this guy as arithmetic series as well. Does it make sense to everybody? Tanvi, how is the first day torture looking like?
It makes sense.
Make sense? Okay. Yeah. Alright. So that's how you'll relate, okay? Now we have a very simplified, a childish way of looking at things. If somebody says, what is arithmetic series? Plus and minus, arithmetic series, multiplication, division, geometric series. We have not talked about geometric series in detail yet. We'll come to that. Let's go back to what we had started with. So if I'm talking about, why I'm starting with 2 all the time? Any idea? 3, 9, 27, 81, 243. Yep. Geometric series, no problem.
Yeah.
Can I have 243, 81, 27, 9, 3, 1, 1 by 3. Same thing. Here, your first term is A, okay? And A is 3. And in this case, we don't call it common difference. We don't denote it by D. We say ratio, because here it's always not. This by this, 9 by 3 is your called a ratio. Basically, the ratio between two consecutive numbers. Okay, ratio of two consecutive numbers. In this case, your ratio is 3. In this case, ratio is 1 by 3. Nobody is nobody is stopping us from calling this a ratio either. It's not written in stone saying ratio always has to be a natural number. It can be a rational number as well. Yeah? So that's why when it comes to geometric series, multiplication, division, both will qualify for being called geometric series or progression. Yeah? Okay. So I know it's almost time for dinner. Many of you must be hungry like me. But let's look at one quick concept. Okay? Like we looked at the nth term in arithmetic series as a plus n minus 1d. What will happen here? 3, 9, 27, 81, 243. I don't know what is next one. What do we see? My first term is
3.
A. I'm generalizing it, okay? What is my second term? A times
3.
R, my ratio. Yeah? What is my third term? On the screen. What is my third term? Dhanushri, Dev, Tanvi, anybody? My first term is A, my second term is A times R. What will be my third term? I'll come to you, just 1 second. Yeah.
Can I answer, sir?
Yes, please.
Oh, it's a times r squared.
Your answer also matching. Now, so what is the observation we are making here? Can I say my first term is a times r to the power 0? Can I say my second term is a times r to the power 1? Can I say my third term is a times r to the power 2? Can I say my nth term is a times r to the power what?
N minus 1.
N minus 1. You see some analogy between these two, right? Here you are adding d, so n minus 1 times d. Here you are taking a ratio, and that ratio is multiplied to find out the nth term. You pick up the first term, multiply that with the ratio to the power n minus 1. Yeah? Did I force you guys to memorize this formula? This is what you guys derived or interpreted based on what we saw here. Now time to complain. Let's see whom did I force to memorize this formula. Be open with me, that's okay. You can say, sir, you're forcing. And I'll fix the problem. Am I forcing anybody? Dhanushri, Dev, Tanvi, Anjani, anybody? Nobody? So no complaints with the teacher then. Okay, cool. That's a good sign. So again, on a serious note, these series that we talk about, they have nothing fancy about it. See, you all would have learned about data patterns, how do you relate the numbers, how do you derive some interpretation of it, from it. This gives some more method to the madness. When you have different patterns, different types of numbers, different group of numbers that you're dealing with, if you see some relationship among them, that is how you extrapolate that and talk about numbers way far down the line without stretching yourself out. So now my job is secure. Tomorrow morning I have to give this report to my boss. I'm compliant. Not because I could do it, because you all learn something. Okay? So Tanvi, there's a bad news. If you're in my class, you'll end up hearing some bad jokes or dad jokes, whatever you call it. But that comes for free, okay? Few jokes in the class. Bear with me. Alright? So that brings us to the end of the class. Any questions before I let you guys go?